In recent years, Malaysia has faced numerous challenges in ensuring food security for its population. With its diverse agricultural sector producing vital commodities like palm oil, rice, cocoa, and rubber, the country has to navigate issues such as price volatility, unpredictable weather patterns, pest infestations, and market access difficulties. Food security is a critical issue worldwide, and Malaysia is no exception. Ensuring a stable, sufficient, and nutritious food supply requires innovative solutions, especially in times of global challenges such as climate change and pandemics. In this video, we will explore how derivatives can be used in agricultural practices in Malaysia to address food security issues.
Hi, my name is Dino Amira. My matric number is F23B0398. I will tell you about the scenario for the problem we want to solve. A scenario is a bioscientist is studying the relationship between the amount of fertilizer used in kilogram and the yield of rice crops in tons. The question is how to determine the amount of fertilizer that maximizes the crop yield. So let's break down the problem step by step. First, we should understand the yield function. The yield function is given by yx equal negative 0.03x squared plus 3s plus 40, where x is the amount of fertilizer used. So to find the maximum yield, we need to identify the critical points of the function. This is done by taking the first derivative of the function and setting it to 0. So the first derivative of yx with respect to x is y x d over dx negative 0.03x squared plus 3x plus 40. And we will do differentiate, and we will get the answer is negative 0.06x plus 3. Oops. Okay. After that, to find the critical point, set the first derivative equal to 0. It means negative 0.06x plus 3 equal 0. Let's find the x. It will be negative 0.06x equals 3. And x equal negative 3 over negative 0.06. And the answer is x equal 50. Okay. To confirm that x equal 50 is the maximum, we check the second derivative of the yield function. So the second derivative yield function is y x equal d square over dx square, then negative 0.03x square plus 3x plus 40. And we will get the answer is equal 0.06. Oh, sorry, negative 0.06. Since the answer is negative, we get is negative, so it's confirmed that the function has a concave downshape at x equal 50.
I'm going to talk about problem 2, optimal harvest times. The growth of a certain crop in Malaysia is modeled by the function gt equal to 30t minus 0.t power of 2, where gt is the growth in centimeters and t is the time in days. Determines the times at which the growth rate is maximized. To find when the growth rates is maximized, we first find the derivative of gt with respect to t. gt equal to 30t minus 0.t power of 2. The derivative if is dg per dt equal to 30 minus 0.6t. To find the maximum growth rates, set the derivative equal to 0 and solve for t. 30 minus 0.6t equal to 0. 0.6t equal to 30. So t, 30 per 0.6 equal to 50. Therefore, the growth rate is maximized at t equal to 50 days.
Next, let's move to the next question, which is about the nutrient-rich compost. So let's see the problem first. In an integrated farming system, a farmer wants to store nutrient-rich compost in cylindrical containers to enhance soil quality for crop growth. So each container must have a volume of 512 cm3 to ensure enough compost is provided for optimal crop development. The cylindrical containers are constructed from sheets of sustainable material. The curved surface is created by rolling a rectangular piece of material, while the top and bottom of are circular pieces that cut out from the material sheet. So to minimize the use of resources and promote sustainability, the total surface of the material sheet used is to make each container must be minimized. So the question is, find the radius of the container in centimeters such that the total surface area of material sheet used is minimized. Let's come up with the data first. V equal to 512 cm3 and total surface area A equal to 2 pi r times width h, which is the body part, and the top and bottom part we got 2 times with 2r square. So this we got A equal to 2 pi rh plus 2 times with 2 square, we got 8r square. So this is the first equation. Let's make h as the subject, which is V equal to 512, and the formula for volume is pi r square h equal to 512. So h equal to 512 over pi r square. So this is the second equation. Next, let's substitute the second equation into the first equation. So we got A equal to pi r square plus 2 pi r. The h we got 512 over pi r square. So we can remove pi and r. Then we got A equal to 8r square plus 1024 over r. Next, let's find the first derivative of area. dA over dr equal to 8 times with 2 we got 16, the square minus 1, 2 minus 1 we got 1, so we don't have to write it, plus 1024 over. Next, to obtain the minimum value, we must make the first derivative equal to 0. So dA over dr equal to 0. So from earlier equation, 16r minus 1024 over r square equal to 0. We time with the r square for all part, we got 16r cube minus 1024 equal to 0. So r cube is equal to 1024 over 16. So we got r cube equal to 64. So r is equal to 4. Next, to confirm whether this r value is minimum or maximum, we need to find the second derivative. So d2a over dr square, we got 16 plus 2048 over r cube. So after we substitute the r value, which is 4, we will got the final answer, which is 48. Thus 48 is greater than 0, then this is the minimum value. So we can conclude that r equal to 4 is the minimum value so we can conclude here, A is minimum when the radius is equal to.
Hi, so this will going to be the last problem for our group. So the fourth problem, which is the last problem, is about optimizing water usage in irrigation. So the problem is the water usage WX in liters per day for an irrigation system depends on the width of X of the irrigation channels in meters and is given by WX equals to 4 by 3 minus 6x2 plus 2x plus 50, and the problem is about to find the width of that minimize water usage. For this question, we need to solve the solution for 12x source of power 2 minus 12 plus 2 and equal to 0. So we need to find this solution by using the quadratic formula, where we get A equal to 12, B equal to negative 12, and C we will get 2. So we need to use this formula, which is X equal to negative B plus minus B source of power 2 minus 4AC, and we must divide by 2A. So what we will need to do is we just fill in that quadratic formula that we will get A, B, C into this formula. Okay, so after we just fill in the A, B, C into this formula, we will get this, and after we solve, we will get 12 plus minus 48 square root divided by 24. Okay, so there are two real roots that we will get. So after we simplify the two radical, we will get 2x which is x number 1, we will get 0.789. Meanwhile, x2, we will get 0.211. Okay, so this is x1 and this is x2. So this is the answer.